There is a wall standing above the ancient city of Cusco in the Peruvian Andes that has defeated every explanation offered for it across 5 centuries of serious inquiry. Not defeated in the sense of remaining merely puzzling, the way old things sometimes resist easy categorization. Defeated in the specific and measurable sense that every method proposed to account for its construction, when tested against the actual physical evidence of what stands there, fails to produce the result. The stones in this wall weigh more than 100 tons each. They are fitted together with tolerances so precise that the joint between adjacent blocks cannot accommodate a sheet of paper along its entire length. They were shaped into irregular polygonal forms, some with more than a dozen distinct faces, each face custom-cut to conform exactly to the specific contours of every neighboring stone. And they have survived, completely intact and completely immovable, through centuries of earthquakes that destroyed every Spanish colonial building constructed above them and around them. The wall did not shake. The wall did not crack. While newer construction fell into rubble on top of it, the ancient foundation held without shifting a single millimeter. That survival is not incidental to the mystery. It is part of the mystery itself, evidence that whoever built this understood the physics of seismic force in ways that our own engineering has only recently begun to match. The site above Cusco is called Sacsayhuaman, and it is the most dramatic expression of a phenomenon that appears across the entire Andean mountain range, from the highlands of Peru into the Altiplano of Bolivia, at sites separated by hundreds of miles but sharing the same impossible fingerprint. Blocks too massive to be moved by any method that has ever been successfully demonstrated. Joints too tight to be explained by any tool that has ever been found at these locations. Surfaces too precise to be produced by the materials that the accepted historical account assigns to the builders. And a consistent pattern of testimony, from the first European witnesses who encountered these walls in the 16th century to the indigenous peoples who were asked directly who built them, that points not toward the civilization credited with their construction but toward something older and stranger that preceded it. To stand in front of these walls and examine them honestly is to experience a specific and disorienting sensation, the sensation of encountering something that your existing framework for understanding the world is not equipped to process. The professional response to that sensation, across generations of archaeologists and historians and engineers, has been to reach for an explanation quickly and hold on to it firmly, because the alternative, acknowledging that a gap exists between what the evidence shows and what current knowledge can account for, is professionally and intellectually uncomfortable in ways that are difficult to overstate. But the gap is there. It has always been there. And the more precisely the walls are measured, the wider it becomes. Begin with the scale, because scale is the first thing that strikes anyone who approaches these sites and the first thing that any honest investigation must confront directly. The largest blocks at Sacsayhuaman are estimated to weigh between 100 and 200 tons. A single one of them outweighs a fully loaded commercial aircraft. They were not quarried from the immediate vicinity of the site. They were brought from distances that, given their mass, represent a logistical challenge that the most commonly offered explanation, ropes, wooden rollers, earthen ramps, and organized human labor, has never been demonstrated to meet. When researchers have attempted controlled experiments to move stones of comparable weight using these methods across terrain of comparable difficulty, the experiments have failed. Not failed in the sense of producing a result that was close but not quite right. Failed in the sense that the physical forces involved, the friction of a 100-ton mass against the earth, the tensile strength of natural fiber rope, the crushing weight that would destroy any wooden roller it rested on, do not resolve into a workable system. The numbers, when you actually calculate them, do not add up to success. But the weight of the stones is almost the lesser part of the problem. What truly resists explanation is not that they were moved but what was done to them before they were placed. Each block at Sacsayhuaman is a unique irregular polygon. No two are the same shape. Each one was cut specifically to occupy one position in the wall and only that position, its faces shaped to conform precisely to the faces of every stone that would eventually surround it. This means that the work of cutting could not proceed independently for different blocks simultaneously, the way modern construction parallelizes its tasks. Each stone depended on its neighbors. Each face had to answer to the specific geometry of adjacent faces that may not even have been fully cut yet. The coordination required to manage that interdependency across hundreds of massive blocks, cutting each one to tolerances that permit no gap and allow for no error, represents a level of planning and execution that the conventional picture of Inca construction does not come close to explaining. The wall does not run straight. This is the detail that reveals the sophistication of the people who designed it, because the zigzag pattern of its face is not decorative. It is military engineering of a high order. The walls step outward and inward in a repeating angular pattern along their entire length, and the effect of this geometry on anyone attempting to assault them is devastating. A straight wall offers defenders only one angle of fire against attackers. The zigzag offers three simultaneously. An attacker pressing against any section of wall finds himself exposed to defenders positioned at the projecting corners to his left and his right, caught in a crossfire from elevated positions while being unable to bring his own force to bear on anything except the wall directly in front of him. The design is not the intuitive choice of people who happen to stack large stones into a defensive barrier. It is the calculated solution of people who understood siege dynamics and translated that understanding into three-dimensional geometry executed in blocks weighing as much as small buildings. The sophistication of the concept and the sophistication of the execution exist at the same level, and both of them exceed what the standard account of Andean prehistory prepares us to expect. The Spanish soldiers who first climbed this slope in 1533 were not men easily impressed. They had crossed an ocean and traversed a continent and conquered an empire. They had seen cities of gold and temples lined with silver plate and the administrative machinery of the most sophisticated indigenous civilization in the Western Hemisphere. When they came upon these walls, their written accounts are unanimous and they are stunned. They described masonry that defied comprehension. They wrote of stones so vast and so perfectly joined that mortal hands could not account for them. Some of them reached the conclusion, stated plainly in the earliest European documents about this site, that what they were looking at could not have been made by human beings at all. We can dismiss that judgment as the superstition of men whose cosmology included demons and miracles. But we should not dismiss it too quickly, because these were experienced builders from a civilization that had constructed cathedrals and aqueducts and fortresses of considerable sophistication, and they were telling us that what they saw here was beyond the range of what they understood human construction to be capable of. That testimony deserves more weight than it usually receives. More significant than Spanish testimony is what the Inca themselves said when they were asked the same question. Who built these walls? The answer the Spanish received was not what they expected. The Inca did not claim these structures. They did not point to their own kings or their own engineers or their own labor forces. They said the walls were already ancient when their civilization arrived in this valley. They spoke of a time before their own history began, of beings they called the Viracochas, creator figures who had shaped the mountains and moved the stone in an era that living memory could not reach. Historians have interpreted these accounts in various ways, as mythology, as metaphor, as a form of borrowed prestige that a rising empire used to elevate itself by association with a legendary past. But strip away the interpretation and consider the raw fact. The people credited with building these walls, when asked whether they built them, said that they did not, and pointed backward towards something older than themselves. 60 kilometers from Cusco, deeper into the valleys that fold between the mountains of the southern Andes, the same questions recur but the scale of the challenge increases. The site called Ollantaytambo sits at the end of the sacred valley where the mountains close in on both sides and the river below runs fast and cold. Above the valley floor, terraces rise toward a summit where 6 enormous monoliths of rose-colored granite stand upright in a row, their surfaces catching the afternoon light and their joints filled with smaller fitted stones placed with the same maddening precision that characterizes everything else in this landscape. Each of these 6 monoliths weighs approximately 50 tons. They are not local stone. The geological signature of this granite traces it to a quarry on the opposite side of the valley, on the face of a different mountain, approximately 4 miles away. 4 miles, stated as a distance, sounds manageable. 4 miles, understood as a physical problem, is not manageable by any method that has been demonstrated to work. To carry a 50-ton block from that quarry to this summit required moving it down the face of one mountain, across the valley floor, across the Urubamba River, and up the face of a second mountain to a height significantly greater than the first. The Urubamba is not a gentle stream. It is a powerful glacial river fed by snowmelt from the surrounding peaks, running fast and cold through a channel it has cut over millennia. Crossing it with a 50-ton granite block, not once but repeatedly for each of the monoliths and the hundreds of other worked stones at this site, represents an engineering challenge for which no proposed ancient solution has ever been tested successfully. The river is simply there, in the middle of the only plausible route, and it does not yield to ropes and rollers and human determination. What makes Ollantaytambo particularly haunting is the evidence of incompletion that surrounds the finished work. Along the route the stones would have had to travel, and at the quarry itself, lie blocks that were never delivered. Archaeologists call them the tired stones, a name that carries within it a kind of melancholy recognition. Some are partially worked, abandoned mid-shaping with the marks of the last tools still visible on their surfaces. Others are completely finished, cut and dressed and ready to take their position in the wall, and yet they lie exactly where they are, on the slope, in the valley, at the river's edge, never having made the journey that their finished companions somehow completed. These abandoned stones are often presented as evidence that the construction process was interrupted, that an earthquake or a military conflict or some other disruption halted the work before it was done. And that explanation may be correct as far as it goes. But it does not answer the harder question the tired stones raise. If the method worked for the monoliths that succeeded, why did identical stones, equally finished, fail to make the same journey? What stopped them at the river, or on the slope, or in the quarry, when others of the same weight and the same material crossed those same obstacles and arrived at the summit? The third major site in this story requires leaving Peru and traveling south and east to Bolivia, up onto the high plateau that sits more than 12,000 feet above sea level near the southern shore of Lake Titicaca. Here, within a sprawling complex of ancient ruins called Tiwanaku, lies a field of scattered and tumbled stone that represents perhaps the most extreme version of the challenge that all these sites present. Its name is Puma Punku. And what distinguishes it from Sacsayhuaman and Ollantaytambo is not primarily the size of its blocks, though some of them are substantial, but the material from which they were made and the nature of the work done to them. The builders of Puma Punku chose andesite and diorite, stones that register at 7 on the Mohs hardness scale, placing them in the same range as quartz and tempered steel. These are materials that defeat bronze completely. A copper or bronze chisel drawn across diorite does not cut it. The chisel loses the exchange. The stone is unaffected. A stone hammer struck against andesite chips the hammer. And yet the blocks at Puma Punku have been cut, drilled, grooved, and finished to tolerances that a modern machinist would recognize and respect. The surfaces are flat to within fractions of a millimeter across several meters of stone. Drill holes are perfectly circular and perfectly straight. Their interiors smooth in a way that suggests high rotational speed rather than manual percussion. Interior corners are cut at precise right angles with a cleanness that power tools produce readily and that hand tools working against stone of this hardness cannot produce at all, not because the concept is wrong but because the physics of the materials involved do not permit it. Bronze is not harder than diorite. You cannot cut a material with something softer than itself, and no amount of patience or technique or organized labor changes that fundamental fact. The blocks themselves carry features that have no parallel in what conventional ancient technology should have been able to produce. Channels of identical depth run across multiple separate blocks, suggesting that the cutting was done to a standard that was maintained consistently across different pieces. Interlocking profiles were cut with sufficient precision that blocks fitted together in the manner of machined components, each one designed to mate with specific others in a system of assembly that implies both prior planning and extraordinary execution. The surfaces carry faint parallel striations in patterns consistent with the motion of a saw or grinding wheel rather than the percussion marks of a stone hammer. These striations have been examined carefully and alternative explanations for them have been proposed, and those explanations deserve consideration. But standing over the actual stone and examining the actual marks, the resemblance to machine tooling is not superficial. It is specific and persistent in ways that resist easy dismissal. The condition of Puma Punku adds another layer of difficulty to an already difficult picture. Unlike the walls of Sacsayhuaman, which stand largely intact, Puma Punku does not look like a site that was simply abandoned and left to weather. It looks like a site that was violently destroyed. The massive blocks lie tumbled and scattered in patterns that suggest sudden and catastrophic force rather than gradual deterioration. Some researchers point to a major seismic event, others to a catastrophic flood, others to deliberate demolition by later peoples who came to the site and for reasons unknown dismantled what they found there. The actual cause remains unknown, and the stones, as always, do not explain themselves. What they do in their scattered state is preserve, in the preservation of each individual worked surface, a record of what was done to them before whatever destroyed their arrangements scattered them across the plateau. That record is the problem, and it does not become less problematic the more carefully it is examined. There is a detail that connects all three of these sites, a small physical feature that appears on massive blocks across the Andean landscape and that has generated significant discussion without generating a consensus explanation. On the surfaces of many of these megaliths, small protrusions remain, knobs or bosses of stone that project outward from an otherwise finished face. The most widely accepted explanation is that these bosses served as attachment points during transport, places where ropes could be lashed to allow a block to be pulled or levered into position. That explanation is reasonable and may be partially correct, but it encounters a difficulty when you look at where many of these bosses are actually located. Some of them are on surfaces that would have been buried against adjacent stones the moment the block reached its final position, tucked into joints where no rope could ever have been attached and from which no leverage could ever have been applied. Others are on the undersides of blocks, facing the ground they rest on, accessible to nothing and no one once the stone was set in place. Whatever function these bosses served, the placement of many of them is inconsistent with the theory that they were simply handles for the moving process. What they actually were and what purpose their specific location served is an open question, and like most open questions about these sites, the honest answer is that we do not know. The conventional framework for understanding these sites rests on a series of assumptions about what the cultures of ancient Andean South America were capable of, technologically and organizationally. Those assumptions are not baseless. There is genuine evidence of sophisticated social organization, of large-scale coordinated labor, of impressive engineering achievements across a range of contexts. The Inca built roads across the Andes that remain engineering marvels. They managed an empire of millions of people across extraordinarily difficult terrain without wheeled vehicles or written language by conventional definition. They were remarkable in ways that do not need to be exaggerated to be impressive. But the specific challenge of these megalithic walls is different in kind from the other impressive things the Inca and their predecessors demonstrably accomplished. It is not a question of organization or determination or the ability to mobilize large numbers of people across difficult terrain. It is a question of whether the tools available could have produced the specific physical results that the stone actually shows. And the answer to that question, when tested experimentally rather than assumed theoretically, has consistently been no. This is the distinction that matters most and that is most consistently blurred in popular treatments of these sites. There is a difference between saying that a thing is difficult and saying that it is impossible. The conventional account leans heavily on the former, emphasizing the extraordinary determination and organizational capacity of the builders, the thousands of workers, the decades of sustained effort, the cultural and religious motivation that could sustain such massive undertakings across generations. All of that may be true and probably is. But determination does not change the hardness of diorite. Organizational capacity does not alter the tensile strength of natural fiber rope. Religious motivation does not reduce the friction between a 100-ton block and the mountainside it is being dragged up. The physical constraints are what they are regardless of the human qualities brought to bear on them. And those constraints, when honestly calculated, do not yield to the conventional explanation. What remains when the conventional account is acknowledged as insufficient is not a comfortable alternative. The alternatives on offer range from the plausible but unproven, a lost technical tradition of the ancient Andean world that left no surviving record of its tools or methods, to the speculative but serious, predecessor civilizations of greater sophistication than our current timeline accounts for, to the genuinely difficult to evaluate, the The possibility that what was accomplished here required knowledge or capability that we have not yet identified or categorized. None of these alternatives comes with the easy reassurance of a textbook answer. All of them require sitting with uncertainty in ways that are uncomfortable. But the discomfort of uncertainty is preferable to the false comfort of an explanation that does not actually explain anything. The walls above Cusco are still there. The monoliths at Ollantaytambo are still there. The scattered precision stonework at Puma Punku is still there. Flat surfaces and perfect drill holes and right-angle corners cut into stone harder than the tools that supposedly cut it, lying tumbled on a Bolivian plateau at 12,000 feet waiting for someone to account for them honestly. They have been waiting for 5 centuries. They have survived every earthquake and every attempt at demolition and every generation of confident explanation that has ultimately failed to bridge the gap between what the stone shows and what our understanding of the past allows. Whoever built these walls understood things that we are still, in the most literal and measurable sense, catching up to. The knowledge is in the stone. The stone has been there all along. What has been missing is not evidence but the willingness to follow it wherever it actually leads, even when it leads somewhere that the existing map of human history does not show.